Cool. All right, welcome back to the show. We've got our friend Stephen Hobbs Jr. here
Yeah, I'm
for a
back.
third episode. Stephen, I think you're officially my second most recurring guest.
All right, damn.
So,
All right,
round of
that is
applause for
very
Stephen.
very interesting. So I'm definitely glad to be back on the show for sure.
Yeah, for
Yep.
sure.
Yep.
Yeah, me too. Glad to have you back.
Yeah.
Okay, so yeah, we're gonna be talking about chapter six of The Myth of Normal by Gabor Mate and
Mhm.
Daniel Mate, I
Okay.
believe.
Yep.
So last time Steven and I were a little out of sync. We got the chapters mixed up, so we talked about chapter five. But this time we got it right, and we're both on the same chapter.
Yep.
So,
Mhm.
chapter six, yeah. Chapter six is very
Very interesting chapter, I think.
yeah, yeah. I think it's the theme of process kind of
Hmm.
has to do a lot with what
Yeah.
Gabor is saying here. Uh,
Yes. Process. Yep.
but yeah, yeah, no, yeah. I'm curious to hear what you think of the chapter overall.
Yeah, it's very interesting. Like I think at first the first thing that really jumped out at me was like how to describe disease, like how to describe that as a process,
Mhm.
and he was saying like we shouldn't say I have cancer, I have disease, I have something. It's like because the cancer is within you, it's like a process that you're going through yourself, so kind of experience, I guess. It's just like if you take a different approach to it, you can find new therapies or different medical interventions to help you heal. So that was the first thing we like was kind of like interesting to me is like don't say you have cancer, say you like you're going through a process of cancer or something like that. Like it's kind of
Mhm.
experience that you go through.
Yeah.
Um, yeah. Also,
You
you
said
said,
you did understand that or you didn't
oh,
like under
I did understand. I did. Yeah, definitely
Oh,
did
okay.
understand that. I did understand that. Yeah. So it was
Gotcha.
very. Yes. I mean, that was very new to me. A very new idea to me. So basically, that was very very cool idea to ponder.
Hmm.
Also, what else? Again, more about the theme of like stress and like adversity and health. Like this is like his third chapter. He does go like what stress responds and like how to cause disease and health issues. But I guess he does go more. I guess be more issues, be more information about the brain, like more.
Hmm.
I think he talks about the hypothalamus,
Right.
basically the master control center in the brain. Yeah,
Hmm.
yeah. He
Yeah.
said basically that controls a lot of different cytokines, immune responses, and like how our heart moves and how like the blood moves, but heart rate and stuff. So he said that actually if you're stressed out or if you feel just a certain emotions, that could be kind of like let's say like kind of what's the word for it? Kind of like I guess kind of like interpreted by the hypothalamus.
Hmm.
And then that can also have an effect on your immune system and some inflammation that can cause disease or even worsen the disease processing. So again, it's
Hmm.
more like I guess like more like um, molecular biology, like about disease and how that the emotion and stress can actually kind of like um, and the kind of inform or different disease and stuff. Yeah,
Yeah.
yeah,
Yeah, no, definitely. And I'd love to get into some of that more like detailed bio stuff in just a
yeah,
minute.
yeah, yeah,
I really like what you said about the kind of thinking about disease as process as he writes in the
yeah,
book.
yeah,
I think about that a lot in terms of mental health. And I
yeah,
think that there's a good case to be made for it with mental health. So it was really interesting for me to see that, it's not just mental health that we can think of this way.
yeah.
Um, like understand that it's not such a distinct um thing or a distinct phenomenon. Like it's very hard to say in
Yeah,
Gapor's view, where does cancer start and where does it end, like officially, because
yeah,
there's so many different factors involved,
yeah.
stress, your upbringing,
A lot of
environmental, I
diet
think it was
stuff.
like
Yeah,
pollution or something, yeah.
yeah, yeah,
So it's cool to see that he has that view of like physiological disease as well. And
yeah, yeah.
I think that's really interesting to think about the body as like a huge system in that way.
Because he
Uh,
was saying basically a lot of diseases known as idiopathic. You basically don't know how it started. But yeah,
Mm.
there's a lot of like it's a long factor, it's a long process. Like you said, we don't even know what difference between healthy and disease because like you be kind of in between those states
Mm-hmm.
at the same time, but sometimes like your body cannot prevent that. But it's just
Mm-hmm.
a process. You don't know where it comes from. It's just you can't really pin on one exact thing. So you gotta really look at it a big picture look at it big picture wise to see like what's actually happening. So
Yeah.
I think he does a good job of saying it's a process. It's not really just one thing. It's more of
Mm-hmm.
just a whole body dysfunction from other factors, so health, this is upbringing, emotional state, diet, or even just like stress can definitely will impact the whole body to cause disease or stress or disease or cancer. In this case, cancer. These or this case is cancer. Yeah,
Yeah.
yeah,
Yeah, definitely. And I think cancer is a really kind of a good case to think about because he mentions this and you know, then I'd like to turn it over to you to get your perspective. He mentions that many people, and we know this through autopsies, I guess, have cancer cells, have
yeah.
you know, the cells for different types of cancer in their
Yeah, I
body.
think they're saying like the woman they saw a woman in the autopsy that they had a lot of breast cancer cells.
Hmm.
But they didn't have breast, but they had cells that were cancerous. So yeah, that's
Hmm.
what they're saying. Yeah. So, yeah. I mean, like you're saying in the book, like usually cancer starts as like a uncontrolled growth, like of a cell.
Hmm.
Also, basically, that is basically as picked up by the immune system, as like known by the immune system to shut that down when it starts
Hmm.
stop cancer from growing. But if you have a certain event, something happens to your immune system, or something happens, you just don't stop that growth, it can cause cancer tumors. So there's
Hmm.
some cells that can be transformed, but they can be like dealt with by the immune system. But also like if that doesn't happen, the cancer can go faster and it can get out of control, and that therefore you cause you have basically have cancer, like you have the disease full on.
Hmm.
Um, yeah, yeah. So that's definitely happened. Just like you have some cells that are transformed cancer cells, and then you have your immune system to kind of catch that or kind of stop that from happening to even going up to a bigger tumor. But if it does do that, you have cancer at that point. So
Mm.
yeah, see, that's usually how it works. Yeah,
Gotcha.
yeah, yeah,
Cool. Yeah, so let's get into more of that bio stuff
yeah,
that you're kind of leading into. So I'm gonna read the quote, so just give me a minute to read
yeah,
this section here.
yeah, yeah.
So he says, this is where stress plays its incendiary role. For example, through the release of inflammatory proteins into the circulation, proteins that instigate damage to DNA and impede DNA repair in the face of malignant transformation. These
Mhm,
proteins, called cytokines, can also inactivate genes that would normally suppress the tumor growth,
mhm.
enable chemical messengers that support the growth and survival of tumor cells, stimulate the branching of blood vessels that bring nutrients to feed the
Yeah,
tumor, and undermine the immune system. Even at the cellular molecular levels, the generation of ill health is a multifaceted, multi-step process. So, again,
mhm,
that kind of idea of disease as a process.
mhm.
Um, but I wanted to hear from you. Could
Mhm.
you kind of unpack all that DNA, cytokine,
Yeah.
protein transport stuff that
So
I
like,
have no
yeah,
idea what it is? Yeah.
yeah. So cytokine is basically just a protein that's created by immune cell that can like have effects on other immune cells or other tissues as well. So it's kind of like they're very diverse. So, like there's like a few classes. There's IL-6, TNF alpha. Like there's a lot of different classes of cytokines, but they do different things as well.
Mm,
But sometimes they're mostly like pro-inflammatory genes. They can kind of like they can actually turn on immune system. Also, that they kind of shut off the immune system at the same time, so it kind of goes up and down.
mm,
I think that was just saying
interesting.
I think that was what he meant. We said like they like basically they inactivate genes that are required for stop cancer.
Mm,
That can
mm,
happen as well as cytokines too. They do that as well. So it definitely is pretty complex protein. So
mm.
um, I think I'm not sure. I never heard cytokines have been doing role in DNA damage before. That's the first time I heard that before. So I never heard
Okay.
it before. So I mean, it makes sense because cytokines can actually activate like cell signaling pathways in the cell, and there's a lot of proteins, a lot of cell signaling pathways can have a huge role in DNA damage. So it does make sense that it can cause that by some. As
What seeking pathways?
huh? So I mean, what? It's like I'm not sure about the exact pathways. I mean, see, there's a few pathways like that can cause like I'm not sure the name
What
of
do you mean by pathways?
like basically like protein cascades like the protein can like it's a cascade or it's a big pathway basically just like a chain event of proteins and proteins kind of bind together but the
Mm,
bind together to have an event or kind of interact with each other to cause the event and
mm,
that like pathway can go from the cell surface to the nucleus and
mm,
that's where the DNA is of course in the nucleus right so it's very complex pathways. It's very simple pathways. So, but it's basically how like a cytokine has a receptor, right? As a receptor on the cell surface, and
mm-hmm,
the receptor causes a downstream like signaling event to cause other like protein interactions in the cell.
mm-hmm,
That causes a protein interaction in the nucleus, and
mm-hmm,
that's where the DNA is, right? So DNA is the nucleus, right? So
mm,
and part of the DNA repair response is to proteins. So
mm-hmm.
I think that's the way how cytokines can like kind of impact DNA damage in that case. I believe so. Yeah.
Okay,
Yeah.
got it. So I'm gonna I'm gonna try to make some little baby steps here because I haven't even done Bio 101 or anything.
Yeah.
So a pathway is basically like a a stream of events that
Yeah.
occurs to make
Yeah.
some biological process
Yeah.
happen.
Yeah. So basically, it's to be yeah, it's kind of like a pathway, more like a series of events of
A
interactions
series of events, okay.
that interact. Basically, like it's called basically one of the events would be like a protein can like phosphorylate another protein, phosphorylate, like kind of add
Mm,
a group to another protein to make it active.
mm,
And
okay.
and this is basically how a protein interaction can make it more active. Then that kind of is a cascade of events, and it keeps going
Mm.
on until that response in the cell is warranted. Yeah.
So I noticed you said cascade of events instead of like a chain of events. Why cascade?
I think
Why is
I mean, I
that?
think like,
Yeah.
I mean, usually like, I mean, that's how I call it really, like in biology is cascade really. I mean, I guess that's the term I use in biology a lot because it's a cascade.
Yeah.
I guess I do that because there's a cascade of like phosphorylation of proteins. Like they like one protein can phosphorylate one protein. That protein can phosphorylate another protein. So it kind of just as
Hmm.
cascade events. Well, I think
Mm.
like, they use a cascade other than chain reaction, but I think that's just what they use for biology reasons. I think so.
So I'm guessing there's multiple chains of events
Yeah,
going going
yeah,
at the same time, and that's why it's kind of like a cascade instead of just like one
yeah. It's
chain.
it's kind of a cascade with one, two, three, four, five. So it kind of keeps going like that.
Mm.
There's a lot of those like cascades are kind of like happening at the same time. So it's very it's kind of
Mm.
they're happening at the same time. Like all these signaling pathways is it's all basically
Yeah.
the machine. So all these are happening at the same time. It's kind of confusing. Yeah.
Would it be appropriate to kind of think of it like a shower? Like it's not
Yeah,
just a single like stream, it's like
yeah, it's
multiple
like two streams, and some
streams.
actually
Okay.
some pathways actually integrate, kind of like cross, kind of like they can integrate with.
Integrate?
Yeah, basically
Oh,
they can like cross speed. You have two pathways going down. They can actually crisscross and kind of interact that way to cause. It's a little very complex. Yeah,
interesting.
yeah, yeah, yeah,
Yeah,
yeah, yeah,
that's cool.
yeah,
Yeah, so it's not just they're like happening, it's
yeah,
not just like they're happening simultaneously, it's they
yeah,
also interact
yeah,
and
yeah, 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 exactly.
kind of interweave. Okay, cool.
Yeah. Mm.
Man. Yeah, I guess I can see what he means by process then. Like it's not
Yeah.
just
Mm.
I don't know, it's not like you just have like a cube or like a block and
Yeah.
like this is
No,
cancer.
no,
It's
it's
like
process of things like
many
yeah,
different
small things. Yeah.
interwoven things.
Yeah.
Okay. Interesting. That really like puts it into better perspective for me. I still don't know what the hell cytokines are or what they do,
Yeah,
but
it's like
uh
the very small proteins that have an effect on like cell signaling pathways in the cell. Basically, they can impact cell behavior. Um, yeah,
Okay.
yeah, that's basically. I think an easy way to know them is just the small proteins that can be secreted in the blood, and they can interact with different cells to cause different events to happen in those cells. If that makes
Okay.
sense. Yeah.
Okay. Gotcha. No, yeah, that does make sense.
Yeah.
Cool. All right. So, for answering that for me.
Yeah.
So, underneath that, I had some other stuff that I highlighted.
Yeah.
Um, kind of again talking about the environment and like the relationship between um I guess like genetics and the environment and how that culminates into the process of disease.
Yeah. Yeah.
Um, did you have any other thoughts about this chapter? This one was a little bit longer than chapter five. So I
Yeah.
was curious if you
I think I think this was like two parts. For one's like just like trying to see like how to describe disease as a process rather than you having it. And then the other part is trying to find like more about the science behind it. Like he does like talk about the hypothalamus, basically just the master control
mm,
of the brain.
hmm
How like how basically that stress can actually like cause that organ or kind of I guess it's sort of structure. Call it structure to kind of disbehave or be this dysfunction. That can also cause
mm,
cytokines to be out of whack and kind of cause your immune cells to be out of whack, and that can cause the process to be kind of out of whack. So
mm.
let me see if I can find. Let me just pull up again.
Yeah.
Uh,
Yeah, while you're doing that,
yeah,
something that you mentioned last time that I
yeah,
thought was pretty interesting was you said that like one kind of mechanism where like disease can occur like through stress basically is that like if the organ is overactive or if it's not acting right, then the tissue can actually degrade. And so I was thinking, since he mentioned the hypothalamus, well, if there's a lot of stress in your hypothalamus, because I'm pretty sure it regulates like heart, or no,
yeah.
does it? Maybe that's more of
Or,
something about the brainstem.
hormones, hormones are basically the hormonal axis is
Okay.
hypothalamus too. So I think basically like so over time, like if you're like your brain can be overworked. I mean, it won't degrade, but it would cause like some of the dysfunction. It won't
Hmm.
like degrade. It won't like, stop working, but it would just cause some
Yeah.
dysfunction that it would usually be during healthy environments or healthy states.
Hmm.
But he said, let
Gotcha.
me see here. Cool.
Yeah, I was thinking like if you're chronically stressed and maybe you
Yeah,
have like an elevated heart rate while your heart's kind of working overtime,
yeah, yeah, yeah,
more than it should.
yeah,
And so I
yeah,
guess it makes sense that like you might have heart problems if your heart's
yeah, yeah, yeah.
working so much because the tissue's, you know, being stressed in a way that's not healthy.
All right, 1 second here. I'm trying to find the last page of that chapter.
For sure. I'll go ahead and pause real quick. And we're back. All right, Stevie, what'd you find?
Yeah, so I think there is a doctor named Dr. Lisa Rankin. She was diagnosed with coronary heart disease.
Mm,
Is that coronary heart disease? And then she had a different two deficiencies as well. She has like very rapid heartbeat,
mm,
really irregular heart palpitations and stuff. So, but they didn't ask her like what did she have, like what other stressors. The doctors didn't ask her what other stressors she had in her life.
mm-hmm,
And so she took a more like different route to her recovery. She took no drugs at all, no medications at all. She just took to like kind of like transforming her life into more like healing, or like kind of being more like positive too. Like she kind of changed her life to be a healer. She leads seminars.
mm-hmm,
Kind of she focuses on mental health too. Mental health. It kind of changes her viewpoint of the disease to be like kind of like a call to change the way how she lives her life, I guess.
mm-hmm.
Less stressful, more healing in that sense. So again, this is again like Dr. Monte just saying, oh, really stress is definitely a huge role in disease for sure. So
Mm-hmm.
just like healing could be just like having less stress, of course. doesn't need to have like medication or anything, medication or drugs, but she took it more like about just being more like more positive and also less stressful as well. So like that's
Yeah.
where I had to address things. It's not by medication, but also by stress as well, because that's plays a huge role. But definitely when by Dr. Monte says these last three chapters is like stress is a huge thing in disease processing, disease and cancer. Yeah,
Yeah.
yeah,
Yeah, and I mean, and it can, involve medicine, right? It
yeah,
can
definitely.
absolutely, and sometimes it does require medicine, but
Yeah, definitely.
kind of what you're pointing to, I think, highlights again like the very social dimension of Gabor Mate's message here is that,
Yeah, yeah.
yes, we could prescribe her these heart medications and these, different physiological therapies for her
Hmm.
heart,
Yeah,
or, another thing that we could do is have a healthier society where
yeah,
doctors in medical training don't have to endure such,
yeah.
harsh circumstances, and where, we can be more kind to each other, and where people can have days where they focus on their mental health, or, they don't have to be overworked so much. Like those are all social systemic problems.
Uh-huh.
And, yes, we can prescribe pills and sometimes we should, depending on what it is, but,
Yeah,
you
yeah.
know, we should also focus on what is our environment, our social environment, for
Hmm.
all the
Yeah,
reasons that you're
yeah,
that you're talking about.
yeah, definitely, definitely. So yeah, the chapter is very cool because it's like after just trying to say like how do we describe cancer and disease that's different, like not saying you have it, but as a process that we go through.
Hmm.
Then how we can like change that process, but trying to live more stress free life, or just trying to be under left more better environments. So yeah, that's
Yeah.
a good chapter for sure.
Yeah. Yeah, it kind of almost, it's like your body's like speaking to you. It's
Yeah,
like, hey, you're
yeah,
way too stressed out. You're in a bad environment. You need to
yeah,
change something.
yeah,
And
yeah,
like, I'm cancer is going to happen if you don't do anything, or this
yeah.
disease or that disease. And he doesn't say it in this chapter, but I just want to say it because it's important. That doesn't mean that we should blame people, because it's not
No, no,
their
yeah,
their
yeah,
fault.
yeah,
But
yeah, yeah,
it does mean that we should look at our culture differently, knowing that, this is how disease occurs and this is how disease can happen.
yeah.
Um, what else was I going to say? Yeah. So, kind of wrapping up, one last thing. I don't know if you saw it, but there's a section, I think it's kind of in the same area that same quote that I read.
Okay.
But it's the part where he's like, people can have cancer cells or malignant tissue, but not
Mm,
develop any
yeah,
actual, like, full-blown disease. Could you talk a little bit about that? How
yeah.
does that happen at the
So
cellular level?
yeah, who makes cells be transformed to be cancerous? Like they're like, I mean, like I think, I mean, when talk about like cells or cancer cells, they're like definitely different cells are healthy, so they tend
Hmm.
faster. They have different they have different sources of like nutrients. That's why basically like so cytokines actually give the cells the blood vessels it needs to grow, the blood vessels, because it goes
Hmm.
to need more O2 oxygen
Hmm.
to actually grow.
Hmm.
But I think it's just like it's like certain like you need a lot of cells to have that cancer grow.
Hmm.
Because in that case, like if it's very low amount of cells, like your like immune system can actually detect it and like kind of kill those cells.
Hmm.
But I think if it's too many cells, it's just like that's you full blown have cancer and your immune cells don't really at that point. Sometimes your immune cells can actually help because inflammation can also cause cancer as well, cause more cancer.
Hmm.
Inflammation causes more cancer. So
Oh, wow.
that case, like the immune system guys kind of help the cancer sometimes.
Oh, wow.
Yeah, so
Kind of make it worse.
you make it worse. So, but I think definitely like when you have a certain like being a few cells that like are cancer cells, and then your immune system just like attack those cells and kills them, I think you're good.
Hmm.
But I guess I don't
Gotcha.
feel like a exact number of cells that like it takes. Like I was not really sure about that, but um,
Hmm.
I guess like it just kind of it's called like a it's called like yeah a threshold that basically you cross, and that's basically you have a tumor, and that can go to more tumor as well. So it's a
Mm.
process for sure. Yeah.
Gotcha.
Yeah.
So
Yeah.
he so I'll read so when he says through the release of inflammatory proteins into the blood circulation,
Mhm.
that's how stress like plays its role
Yeah. Yeah.
in the
Yeah.
development of cancer. Is that kind of what you're talking about?
Yeah, yeah, because yeah, cancer, yeah, because basically it's something, yeah, yeah, of course, inflammation is actually mostly bad for cancer because it's called like damage and it's kind of like stress, and it can cause more cancer to grow. It's really complex process, but you definitely if you're stressed out, you definitely can have more inflammation.
Hmm.
Inflammation can cancer too, so it's really
Yeah.
a very like complex system for sure. Yeah.
What is inflammation at the cellular level? Because I hear a lot about inflammation, but I don't actually know what that means in terms of like our cells.
Cells basically it means you have basically a large amount of immune cells at like one point. Like you basically have an overactive like you have you have basically your immune cells are really like I guess over
Mm.
basically we have like when you cut your finger or you have a break in your bone, your immune cells they become active,
Mm.
inflammation. Also they also your blood vessels they dilate to make sure the immune cells can actually pass through the vessels to get to the site of injury or site of cancer. Because
Mm.
process, it can be fever. It's a whole different process, but mostly it means like immune cells like being active in a certain area. Yeah,
Okay.
yeah, yeah,
Gotcha.
yeah.
So it's like chronic flooding of immune cells that don't necessarily need to be there.
Yeah, but I mean, some it does, but
Or
most times it really
okay.
depends. Like basically it's kind of just a response to something is a response to some injury or stress or some like illness or just a response by the immune system. So it causes the overactive to kind of go to a certain area and it causes pain. It means because you see basically when you get like when you get like a cut, it's very painful and stuff. Like it's basically also because when you like when you see swelling, right? Swelling, the swelling of your
Mm.
bone because also inflammation, a lot of inflammation because your bones is broken, so your immune cell is going through the site of injury. So it's if a lot. It's basically it's a whole process. It's really not that simple for sure. Yeah, yeah, yeah.
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 Gotcha. Cool. Yeah, no, definitely. That's why we have guys like you who are really smart with this stuff to figure that out.
Sure, for sure. Yeah.
Uh, cool. Last thing, is there anything, and if there's not, that's okay, but are there any implications for the stuff that Dr. Mate is saying on your research and this or the stuff that you study?
Let's see. Um,
And if there's not, that's, that's fine.
I don't really study inflammation that much. But I do know much. I know something about it. I do know like sometimes that there could be. I do want to look into. I think I'm going to look into at some point like how my protein is involved in the cross talk between cells of immune cells, also cancer cells. The cancer cells, immune cells, they also like they do a cross talk. Guess like, always in kind of like guess a dialogue or kind of like conversation with each other. The cross talk.
Hmm.
So I
Immune
definitely
cells and cancer cells?
yeah, they do interact with each other. Yeah.
Okay,
Sometimes like
interesting.
sometimes some certain immune cells can actually like cause tumor cells to be more overactive and go faster. So um
Oh, wow.
yeah,
So they
so
can actually worsen cancer
yeah,
in
exactly.
some
Yeah.
ways. Wow,
Yeah.
interesting. I did
Right.
not know that.
Yeah, but that's one thing I do know about what I'm doing is I do want to look at some point the tumor microenvironment was basically like do you know what that is? Tumor microenvironment. Tumor microenvironment.
Mm.
It's just like
Nope.
a microenvironment of like immune cells, cancer cells, like collagen based like kind of ECM, the extracellular matrix and stuff. Um,
Mm.
certain like some like certain proteins and inside proteins. So basically, it's kind of like a little environment of like the cancer, the immune cells, the collagen fibers, all different. The ECM material, also certain cytokines to cytokines there as well. So,
Mm.
but more is that it's kind of like more of that like that's being like very it's a very hot topic today. Hot topic today in biology is kind of like how to decipher like the immune the tumor microenvironment and how to make it more anti-cancer, I guess. That rather than being pro-cancer. That makes sense.
Okay.
Yeah, yeah,
Interesting. Yeah.
yeah,
And maybe, some of that has to do with what Dr. Mate's saying.
yeah,
Um,
yeah,
and I wouldn't know how that trickles its way down to the cellular level, but I'm
yeah,
sure,
yeah.
you know, all those factors could play a role in some way, and I'm sure they do.
Definitely, 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 definitely. Yeah.
Cool. Well, man, it was good having you on. Did you have any last thoughts about chapter 6?
I don't think so. I think we discussed all that, all that we found most interesting about this chapter. So yeah, it's
Yeah,
definitely a good chapter. Yeah,
yeah, for sure. Well, cool. All right, man. Well, it was good having you. Good
yeah,
discussion, and we'll have you back on for a future chapter.
yeah. I'm down. All
All
right,
right. Peace
peace
out,
out.
Stevie.
Yeah,
Good having you.
bye bye.